The geometric series. So hello and welcome, Charlotte. Hope you are bopping along. Maybe Swifties look directly at you or pointed. And it's not going to be a cruel summer. Anyway, so here we go. As soon as we see geometric sequence, we write down our formula. We remember that A is the first term of the sequence. R is the ratio, remembering it's the second term divided by the first term, etc., etc. All right, here we go. The 12th term of a geometric sequence is 2. So when we write that, we convert it straight to mathematics. So T12 equals 2. The 15th term is 54. This is nothing new to what we did with arithmetic. Do you agree? The only difference is when we sub it in now, we sub it into our formula, we get 54 equals A times the ratio, which we don't know, 15 take 1, so we say it's to the power of 14. Is this coming back to us a little bit? And for this one, we're going to do exactly the same thing. So 2 is our term. A, we don't know. We still don't know the ratio, Horatio. N is your 12, so 12 take 1 is 11. You've got two equations with two unknowns, so we're going to solve them simultaneously, but these aren't linear simultaneous equations. These are, well, those. So the trick that we do, 54 equals A times R to the 14. We're going to divide it by, so little divide there, 2, equals A times R to the 11. Now the bonus of when we do this, 54 divided by 2, 27. What's A divided by A? 1, so that cancels out. But here I've got R to the 14 divided by R to the 11. I'm dividing by the same base. When I divide by the same base, what do we do to our powers? We subtract them. So this then becomes R to the power of 3. How do we solve this? Well, we can take the cube root on our calculator. We already know that 3 cubed is 27, right? But imagine that was a harder number. If that was R to the 4 or R to the whatever, 11, or this was 127. We can get rid of the cube by cube rooting, which is the same as 27 to the 1/3. So if I ever had something like R equals, I don't know, the 5th root of 110, we can type that in, or we can say 110 to the 1/5. Okay? Do we remember how to pop that into our calc? Yep. Do I need to show you? Yay, no? Oh, that was shaking of the heads. Good-o. So they're just going along. Do you need a little bit more time to progress and finish this exercise before we look at the series? Yes? Yep, okay. If you don't say yes, right, I'm just going to go, right, let's go on to the next bit. So if you have finished, you can read the next bit, or you put your hand up and I'll come to you. Otherwise, let's keep going. Do we have some questions from here that we looked at and we went, not quite sure what to do? Oh, sorry, I need to finish the answer. So R is 3. Find the 7th term. So when R is 3, we can pop it back into either one of these. So we can then go 2 equals A times 3 to the 11. Wowza. Yes? And therefore A will be 2 over 3 to the 11. Bit disgusting, but that's okay. So therefore what were we after? The 7th term. So T7 will equal, I'm following the formula now, A. We now know that A is 2 over 3 to the 11 times our 3 and n take 1, so to the 6. So we're going to pop that into the calculator. If it said, leave this as an exact answer, can you see where you could simplify this at all? Remember this, 2/3, that's like that goes all the way across. So now once again, I'm dividing by the same base. What can I do to my powers? Correct. So I could leave this as 2 over 3. So 6 take 11 is -5. So it puts it downstairs as So if it said, leave it as an exact answer, we're done. If it didn't, go to your calculator. Can anyone predict, if I go to my calculator, what's going to happen? 2 divided by, now 3 to the 5 is a reasonably large number, do we agree? So I'm hoping what's going to happen. Oh, would you like my graph that we were just doing in Spec Maths? Modulus. Did you like that? You like that? So 2 over 3 to the 5. No one's freaked by this? That's just your scientific notation. So probably go to 3 significant figures. So 8.23 times 10 to the minus 3 or 0.00823. Bye, please. So up to 19 for the geometric sequences. You can have a look. There's a couple of questions there when we're talking about the money. Still waiting for everyone. There's a couple of questions when we're talking about the money stuff. Now, sometimes the money gets, I'll pick up that pen and throw it out. The money gets lost in some of our year levels, and it's really sometimes the most crucial thing that we can do. I know you remember simple interest, I equals PRT over 100. The compound interest formula is we go future value equals present value, so what money you have to invest now, and we have 1 plus I being your interest rate, to the n. Now, why do we add on that 1? Because we're increasing it by that percentage every year. So the 1 represents a whole 100%. You right? What's going on, boys? Well, not right now. So this is a formula we know and love. Now they're trying to force this, and they're trying to force it into the geometric ratio. Okay, so our geometric ratio is TA times R to the n take 1. So A will still be the original amount that you invest or borrow. Your ratio is what you are increasing. So your 1 plus I is just your increasing amount. So if I'm increasing my savings by 4% every time, that means we're doing the multiplying by 1.04. That's why that goes in there. Agreed? Remember that a little bit from maybe percentages in previous years? What about if you were decreasing? So you're in the, we're having high inflation at the moment, but if things were deflating, if you were decreasing by 4%, what do you multiply by then? Excellent. You take that 4 away from 100, so you would multiply by 0.96. So just be careful when you're watching those ratios. That's how we get it. Now, all they're doing with some of the questions is they're changing it to the end of the year to make it fit the geometric ratio. I want to show you how geometric ratios fit in, sequences fit in with this, but I really don't want you to change this formula. So all your questions will still work using that formula. We're sort of just chucking some of that in rather than doing the geometric sequence. So I guess I should have taken those questions out, but they're still good for you to have a little bit of money. Otherwise, methods and spec kids don't get any sort of look into that. Which reminds me that sometime this year I'll show you how to do it on your calculator where you're saving by payments and doing loans. So good. General maths might do it. I better pause that. Right. So what we then want to do after you've done your sequences, and I'm going to sign your books to check that you got your homework done by now. After we've done our geo sequence, we then want to look at geometric series. So this is building to your formula page. All right? We should have that in our textbooks. So we've got Tn equals A r to the n take 1, and now we're going to have the sum of a geometric series. And we're going to have two formulas. We're not going to be panicked by this. To be honest with you, I use either one and it works for me. Okay, so very briefly. It looks like there's 3 formulas, but really there's only 2. Because please notice that this one, it's just saying it's more convenient. All they've done is times through this by with a negative, right? But it's the same formula. It's just avoiding some minuses sometimes. I don't bother. I tend to just use the one because my algebra's not too bad. Less things to remember. But as we go through, you'll see. Now, both of these, we just keep adding on. And so it keeps growing and growing and growing and growing. Agreed? However, what can happen is if your ratio is less than 1, but greater than minus 1, right? So 0.25 minus 0.25. What then happens is it doesn't keep growing. Well, I guess it can keep on going and going and going, but it's what we call it converges to a single point. And that's what they're saying is as it keeps going and getting bigger and bigger and bigger, it's not going to make a massive difference to what is happening. So Charlotte, I'm about to perform a bit of a situation to show them, and I'm ripping up a piece of paper. You might want to think of halving a glass of soda. Okay, you keep halving it, you keep halving it, you keep halving it. You're getting down to like a drop, but it keeps on going. But it will, if you put all of those bits together, it will still form that original 1 glass of soda. Does that make sense? Look for the word common ratio or geometric, and it means you go here. If it says arithmetic, then you go to the other. All right? If the ratio is between 1 and minus 1, we know it converges, and then we use that formula. Agreed? Do we want to do a couple of questions, or you think you can handle it? Do a couple? I heard do a couple. We're going to go straight for C because we think we're in the zone now and we're pretty decent at this sort of stuff. So we're reading the question. Remember, these are going to be all mixed up in your test. We read, find the specified. The key word is sum, and then we've got geometric. As soon as we see that, we're looking at this formula here. And now we're going to go through and we're going to see what do we need. We need the A, we need the R, and preferably we need the N. So do we have all of that? Do we have A? Spot on. We've got A is minus 4 over 3. Do we have the ratio? Not yet, but we can find it. What was the one thing you had to remember about the ratio? Second term divided by the first one. And technically you should just grab your calculator out and double check. That divided by that, do minus 1/3 divided by, do they equal the same? Because if they don't, then it's not a geometric. Okay, so we're going to divide by minus 4 over 3. You can plop that in your calculator, but I can't be stuffed. So it's minus 3 over 4. The 3's cancel, so I get minus 1/2. Now we just talked about this because this is between 1 and minus 1. If it was asking us to find out what is the sum of that and they didn't actually have that there, I would go straight to this formula. But because they're actually asking for the first 9 terms and 9 terms only, then I'm going to be using this one. Yes? So reading, that gives me N is 9. So I've got everything I need. I've got the A, I've got the R is minus 1/2. Sorry about my squishiness. I just wanted to keep the formula up there. So we'll pop that down here. And therefore I've got R is minus 1/2. Okay? I got the A, got the R, got the N. And it's now your calculator that does all of the work for you. A minus 4/3. Please yell a bit more. Watching my year 9s do some of their work. They don't care about brackets anymore. They could just ignore the negative if they want to. You know, what's the hypotenuse? Doesn't matter. So make sure that we have got those brackets there and dividing by 1 take r. So 1 take a half, so plus 1/2, and away we go. Is it difficult? No. Is it fiddly? Yes. Do you have to be careful with your notation and everything? Please do so. Make sure you can use your calculator nicely. Okay? We've done one of these before. If this was a test question, it would definitely say, well, actually it doesn't have to say geometric. It's just saying the sum. So the first thing that we would do is we would check phrase. I know it's under the geometric series, but why is it geometric and why is it not arithmetic? Where am I multiplying? So let's rephrase it. Why is this not an Sammy? Why is this not an arithmetic sequence? There is no common difference, right? Minus 6 take 2 is minus 8. 18 take 6 is 12. So can't be arithmetic. So then we go through and we check, okay, is it geometric? What's minus 6 divided by 2? Minus 3. What's 18 divided by minus 6? Oh, it's minus 3. It is now geometric. So it might not even tell you. You would have to just look, check, which one is it? Okay. It doesn't tell us what we want to sum up to. So what are we going to do? Good mathematicians? We're going to write our formula because it's sum of a geometric. So Sn, right? Sn equals A 1 minus r to the n over 1 take r. So we need to get all of that information. What have we got? We've got A is 2. We've got the r is minus 3, but we don't know the n. Now, not to give any secrets away, but you did a question exactly like this in your worksheet just before, but instead of geometric, it was arithmetic. And what did, I don't know if you remember, but what did we have to do to find the n with the arithmetic? You had to go back to your general formula of a sequence. So we're going to do that with this. We're going to go back to our original formula for our geometric. Change of colour is needed. So we have Tn equals A times r to the n take 1. Agreed? Why are we using that? Because this is our Tn. We have the A, we have the r. We're going to use that to hopefully find our n. Agreed? So I've got 4 minutes. We're going to refresh on how you use logarithms as well now. So here we go. 1, 4, 5, 8 equals my A. It's all written here nicely for me. 2 times minus 3 to the n take 1. And I'll just pause for a minute so people can catch up. Yes, we're going to get rid of the times 2. We'll divide by 2. So 7, 2, 9. Yes? Okay, so hopefully everybody out there definitely knows how to use their calculator. I'm just going to remind you again. So we go over here. We're going to go option, calc. I forgot what I just wrote then. What was it? 7. Oops. Got a bit excited. Solve n. 7, 2, 9. Yes, that sounded familiar. Equals. So your equals button is above your decimal. Bracket minus 3 to the x take 1. I know our thingy said n, but your calculator doesn't mind. We close our brackets. Yes, there could be multiple answers. Oh, well, that's not very nice. Thank you very much, Solvan, and that's on video. So when that happens, trust me, 7. You'll see why in a minute. Because when you take a negative to an even power, right, and then the take 1, we'll be okay. Yes? The equal sign is above your decimal. So see how there's a yellow? So you have to press shift equals. So we know it's going to be 7. How can we prove this? All right, back from year 10, you might vaguely remember when you've got log a to the n, there's this groovy little rule, right? Brings the n downstairs. Do you remember that? So in order to do this algebraically, we can just log both sides. So we log 729. We're ignoring that bit there, right? Is going to be log 3 to the n take 1, log 729. We can bring this down so it becomes n take 1 times log 3. Remember, log 3 is just a number. How do I get rid of that times log 3? You can divide. You could expand the brackets if you wanted to, but I'm going to go with the divide method. So it's going to be log 729, bless you, over log 3. That's going to equal n take 1. So we can pop that in our calculator. Notice I'm only using my calculator once. Get rid of the take 1, add 1, and we should get 7. Okay? When you pop it back in, 7 take 1 is 6, and we know that anything up here, anything to the power of 6 will give me my even number. So that's why we don't worry about that negative there. We good?